Hi, this tutorial covers the standard deviation. So it's important to be able to measure variation or spread of a data set. There are really four main common measures of center, and they are range, IQR, variance, and standard deviation. So this tutorial is going to concentrate on the variance and the standard deviation. All right, so let's take a look at a data set. I really love drinking coffee, and I drink a lot of it, so I was interested in knowing if my colleagues drink about the same amount of coffee as I do. So I asked five of my colleagues how many cups of coffee they've had today. Here's the data I collected. So let's do a couple things with this data set first right off the bat. So let's start by calculating the sample mean. Okay, since this is only a sample, we're going to use our sample statistics. So let's start by adding up all of the values, taking the sum, so that ends up being 10, and then I'm going to divide by the sample size, which is 5. So my sample mean here is 2. So on average, these 5 people drink 2 cups of coffee. On average, have drank 2 cups of coffee today. All right, the next thing we're going to do is make a dot plot of this data. Okay, so I'm going to start with the number line, and then I'm just going to go ahead and mark my data values. So 2, 1, 5, 2, and 0. Okay, so what I want to do is quantify or measure what the spread of this data set is. So what I'm going to do is draw in what are called deviations. Deviations are always how far a data value is from the mean. Okay, and the mean here is 2. So what I'm going to do is just mark in kind of a dashed line here where the mean is. So the mean is at 2. So let's start with this value. This is the furthest one away. So let's draw in a deviation. So this deviation, the length of that deviation is 3 units. And since that's above the mean, that's going to be a deviation of positive 3 units. Okay, if we go over to 1, this number now is below the mean. So this person drank less than average. That has a deviation of negative 1. Okay, the deviation for 0. So let's draw our deviation here. This deviation is negative 2. Okay, and then the deviations for these two people are obviously 0 because they drank the same as the mean. All right, so one way you might want to kind of think about is, well, what happens if I just wanted to find like the average deviation? So what I'd do is I'd add up all these deviations, 3 plus 0 plus 0 plus negative 1 plus negative 2. Well, if you add up those three numbers, you're going to get 0. And actually, anytime you try to find the sum of some deviations, you're going to get 0. Okay, so that doesn't really provide us any meaningful because you'll always get 0. So we need another way, and we're actually going to use these deviations in calculating what's called the standard deviation. All right, so to measure the spread, we're going to use both the variance and the standard deviation. So the standard deviation is the typical, okay? It's not the average. Remember, if you try to do an average deviation, you're just going to get 0. So we're going to do what's called the typical distance. So it's the typical distance an observed data value should be from the mean. And the variance is simply the standard deviation squared. Okay, so let's take a look at some formulas now. So I have 4 formulas here. I have variance formulas here and here, and I have standard deviation formulas here and here. The other distinction is whether you're dealing with a population or a sample. Now, a population, we're going to denote both of those two, both the variance and the standard deviation, with the Greek letter sigma. Okay, sigma kind of looks like a cannon almost, but it's the Greek letter sigma. It's a lowercase sigma. And for anything that involves a sample, either a variance or a standard deviation, we're going to use the regular letter S. So population sigma, sample is S. Okay, now if we look at the difference between the two formulas, if you're dealing with a population with sigma, you're only dividing by n. For sample, you're dividing by n minus 1. Okay, notice that's the same, n minus 1, n minus 1. Basically, if you have a sample, and well, generally with a population, variance and standard deviation, remember, rarely are you going to have an entire population. So we're really not going to use these formulas too much. We're going to use these formulas a lot more. So let's take a look at the sample variance formula. The sample variance is S squared. sample standard deviation is S. So once you have the variance, all you need to do is just take the square root of that to get the standard deviation. So the variance formula is, now this is capital sigma, remember it's summation notation. So that means it's the sum. Now it's x minus x bar, a data value minus the mean. So really this is your deviation. This is what we were calculating before. It's all of your deviations squared, and then it's all of those squared deviations summed. So add it all together. Once you have that, you divide by n minus 1, where n is your sample size. Okay, once you have your variance, then you are going to square root that to find your standard deviation. Okay, so let's actually calculate the sample variance and sample standard deviation for the coffee example. So what I'm going to do is start with my data set. So I'm going to make this as a table. I think it's really helpful to have your data values in a table. And now off to the side here, or down here, I'm going to write down my my variance formula. Okay, so the first thing we want to do is in our table, let's write down what our deviations were. So x minus x bar, those again are our deviations. Okay, and remember that x bar was equal to 2. Okay, so we wanted to do, so 2 minus 2 is 0. 1 minus 2 was negative 1. These are the same values we had on our dot plot. 5 minus 2, positive 3. 2 minus 2 is 0. 0 minus 2 is negative 2. Okay, so that's basically all of our deviations. But we don't just want our deviations, because if we added all those up, that gives me 0. We want our squared deviations. And now why would we square our deviations? Because whenever you square something, you always get a positive number. That'll make all of these numbers positive so that we can take the sum of a bunch of positive numbers. So 0 squared is 0. Negative 1 squared is negative 1 times negative 1, which is positive 1. 3 times 3, 3 squared is 9. 0 times 0 is 0. Negative 2 times negative 2 is positive 4. Okay, so that basically gives me x minus x bar squared for all of my values. Now what I want is I want the sum of x minus x bar squared. So I need to add up all these values. Okay, and that's pretty easy. 1 plus 9 plus 0 plus 4 ends up being 14. Okay, so that's the number that I'm going to use on the top of my variance formula. So s squared now is going to equal 14 over n minus 1. Well, n is 5 because we had 5 data values minus 1. So that's 14 divided by 4. Okay, so as a decimal, 14 divided by 4 ends up being 3.5. So this is your variance. Your variance is 3.5. Okay, so that's your sample variance. Okay, and now to get our sample standard deviation, S, you simply take the square root of 3.5. Okay, and if we do that on the calculator, the square root of 3.5 ends up being about 1.871. So S here is 1.871. So this value is our sample standard deviation. Okay, so once you find your variance, you can always just take the square root of your variance to get your standard deviation. Okay, so that is your process in finding a standard deviation. Usually a calculator or a computer can calculate sample standard deviation by hand, because this does take a little bit of work, but again, you can usually calculate those on a computer or a calculator. Okay, and then the last thing is just to interpret your standard deviation. So notice I have the mean and the sample standard deviation here. So to interpret that value, those two values, I'd say the mean number of cups of coffee drank by my colleagues is 2, but the number typically differs from the mean by about 1.871 cups. So as long as it's within about 1.87 cups of 2, either above or below 2, it's going to be considered somebody that's typical. All right, so that has been your tutorial on standard deviation. Thanks for watching.